Now, let's understand about the construction of lathe machine. A simple lathe comprises of a bed made of grey cast iron on which headstock, tailstock, carriage and other components of lathe are mounted. This particular figure here shows the different parts of engine lathe or a center lathe. The main part would be the bed, headstock, tailstock, carriage, the feed mechanism and the thread cutting mechanism. So let's discuss them one by one. The bed of a lathe machine is the base on which all other parts of the lathe are mounted. It is massive and rigid single piece casting made to support other active parts of lathe. On left end of the bed, headstock of lathe machine is located, while on right side, tailstock is located. The carriage of the machine rests over the bed and slides on it. On the top of the bed, there are two sets of guide waves or inner waves and outer waves. The inner waves provide sliding surface for the tailstock and the outer ways for the carriage. The guide ways of the lathe bed can be flat and inverted V shape. Generally, cast iron alloyed with nickel and chromium material is used for manufacturing of the lathe bed. Next we have the headstock. The main function of headstock is to transmit power to the different part of the lathe. It comprises of the headstock casting to accommodate all the parts within it, including the gear train arrangement. The main spindle is adjusted in it, which possesses live center to which the work can be attached. It supports the work and revolves with the work. The cone pulley is also attached with this arrangement, which is used to get various spindle speed through electric motor. The back gear arrangement is used for obtaining a wide range of slower speeds. Some gears, called change wheels, are used to produce different velocity ratio required for thread cutting. Then we have the tailstock. This particular figure here shows the tailstock of a central lathe, which is commonly used for the objective of primarily giving an outer bearing and support the circular job being turned on centers. Tailstock can be easily set up or adjusted for alignment or non-alignment with respect to the spindle center and carries a center called dead center for supporting one end of the work. Both live and dead centers have 60-degree conical points to fit center holes in the circular job. The other end tapering to allow for good fitting into the spindles. The dead center can be mounted in ball bearing so that it rotates with the job, avoiding friction of the job with dead center, as it is important to hold heavy jobs. Then we have the carriage. The carriage is mounted on the outer guide ways of lathe bed, and it can move in a direction parallel to the spindle axis. It comprises of important parts such as apron, cross slide, saddle compound rest and tool post. The lower part of the carriage is termed the apron, in which there are gears to constitute apron mechanism for adjusting the direction of the feed using clutch mechanism and the split half nut for automatic feed. The cross slide is basically mounted on the carriage. which generally travels at right angles to the spindle axis. On the cross slide, a saddle is mounted in which the compound rest is adjusted, which can rotate and fix to any desired angle. The compound rest slide is actuated by a screw which rotates in a nut fixed to the saddle. The tool post is an important part of carriage, which fits in a T-slot in the compound rest and holds the tool holder in place by the tool post screw, as you can see here in this particular figure. And then we have the feed mechanism. Feed mechanism is the combination of different units through which motion of headstock spindle is transmitted to the carriage of lathe machine. All the controls of a feed mechanism is explained here. H1 here is the geared headstock housing. H2 is the intermediate gear lever. H3 is the high-low gear lever. H4 is a camlock spindle. H5 is a tumbler gear, which is used for forward and reverse and for engaging and disengaging. H6 is the quick change gearbox. It has 4 selectors and 3 levers. H7 is for lead screw operation. H8 is for feed screw. H9 is for forward reverse switch, and H10 is to change the gear. The gearing at the end of bed transmits the rotary motion of a headstock spindle to the feed gearbox. Through the feed gearbox, the motion is further transmitted either to the feed shaft or lead screw, depending on whether the lathe machine is being used for plane turning or screw cutting. The feed gearbox contains a number of different sizes of gears. The feed gearbox provides a means to alter the rate of feed and the ratio between revolution of the headstock spindle and the moment of carriage for thread cutting, which is by changing the speed of rotation of the feed rod or the lead screw. The apron is fitted to the saddle. It contains gears and clutches to transmit motion from the feed rod to the carriage, and the half nut which engages with the lead screw during cutting threads. And then we have the thread cutting mechanism. The half nut or split nut is used for thread cutting in a lathe. It engages or disengages the carriage with the lead screw so that the rotation of the lead screw is used to transverse the tool along the workpiece to cut screw threads. The direction in which the carriage moves depends upon the position of the feed reverse lever on the headstock.